Hello guys, I am Nithishri S. Bagalwadi, Sankalp Learning Solutions, your science teacher. So in the last class, we discussed regarding the lenses, okay, how the images will be formed or what are the construction of the convex lens and the terms involved in the convex lens. Today we are going to discuss in detail regarding many cases when an object is placed at certain position, how the images will be formed, especially in the convex lens. So let us proceed. In the last session, I have covered when an object is placed at an infinite distance, what will be the case of the image in through the convex lens. So let me just brush up that thing. So at the case 1, when an object is placed at the infinite distance, so the parallel beam of light are incident on the convex lens. They will undergo refraction and they meet at a point which is a principal focus. So here the image will be formed when an object will be at infinite distance. This is one thing. The next one is here the nature of a image will be real, means that image will be caught on a screen. Inverted means if an object will be OP, so it will be PO. That diminished means light, it is not a bigger, it will be smaller than compared to the object. Next, in the second case, what happened? We will take an object beyond 2f2. We will take an object beyond 2f2. So what is beyond 2f2? Here you can see children, 2f2 is nothing but double than the focal length. Double than the focal means center of curvature. 2f2 is nothing but a center of that sphere from which this spherical surface has been derived. So when an object is placed beyond 2f2, not at infinity, beyond 2f2, so we will consider two rays here. We will consider two rays. One is incident on an spherical surface, that is on the lens parallelly. So it is incident parallelly. This is the direction. Okay. It is incident parallelly and an image will be formed, that is it will meet the principal axis at a point that is f1, principal focus. Next, let us consider one more ray of light passing through the optical center, through the optic center of a lens. So when a ray of light passes through a optic center of a lens, we know that the refracted ray retrieves back. Okay, so that is why it follows the same path like this, and where these two refracted rays meet, that is the point where the image will be formed. So the image will be formed in between f1 and 2f1. That is, image will be formed at the distance greater than the focal length, lesser than the twice of focal length, lesser than twice of focal length, greater than the focal length. Focal length means distance between the optic center and the principal focus. So this distance, it is formed beyond the focal length, less than the twice of the focal length or a center of curvature. And the nature of image will be diminished, smaller in size than compared to an object, real, caught on a screen, inverted. If this is PQ and this will be QP, inverted. This is the case. In the next case, what happens here? We will bring the object near to the lens. We will bring an object near to the lens. So we will keep an object at 2f2. 2f2 means twice of a focal length. The distance will be twice of a focal length from the optic center. Okay. Now, let us take two rays here. Okay. Don't forget to mention the direction of the light rays. So, the parallel beam of light is passed and met a principal axis at this point, which is a principal focus. I consider it as f1. Next, one more ray is passing through the optic center and it is remain undeviated. Both the refracted rays meet at a point. So, they will meet at a point that is at a 2f1, means that is equidistant from the optic center. When an object is placed at the twice of focal length of one side, an image will be formed at twice of focal length of other side. So here the nature of an image will be magnified, that is larger in size compared to an object. It will be real and it will be inverted. It will be real and inverted and not magnified here. The size of an image will be equal to, not larger, it will be equal to the size of an object. Okay. Now, in the case 4, what happens? Let us place an object between the focal length, that is principal focus, and twice of a focal length, that is principal focus and the center of curvature. When we place an object here, let us take again two rays. One is incident parallelly, other one is passing through the optic center. So when we go beyond, the board is this much only, so I couldn't make up. So I made the rays to meet at a point here. So they will meet at certain point which is beyond the twice of focal length. The image will be formed very far from the optic center. So that is why the image will be larger in size than compared to an object. So it is called as magnified image. Okay. And here in this case magnification will be 1 because object size and the image size is same. Height is same. So h by h cancels. It will be 1. So here an image size will be larger than compared to an object and it is formed far from the optic center of a lens. So the nature is magnified, real and inverted. This is the case. So in these all 4 cases we learned the nature of the images. Now let us think, when we place an object at f2 at the principal focus, so a parallel beam of light again, okay. So here we will keep it as at f2 and not at 2f2. So let us place an object here. Let us consider 2 rays. Okay, let us consider 2 rays, and when we extend those 2 rays, when the object is placed at the principal focus, when we extend, the rays will not meet at all. So the image will be formed at the infinite distance, which will be diminished image, but it will be virtual, which cannot be obtained on the screen. So this is the case when we place an object at a principal focus. In today's class, we learned regarding the cases of the convex lens, how the images will be formed in the convex lens when the position of an object will be changed. So in the next class, we will learn few more cases and we will also learn the image formation by the concave lens. Until that, learn science, observe science. Have a nice day.